We did the B's, right?
Yes.
27.0. Now, if you have 26.9, that's the same answer. My book may have rounded up. You might have a different answer. If your answer is in the ballpark of mine, it is the same answer. We are not all going to round the same way. Okay? If you have the same number of significant digits and you are close to my answer, it is correct. Number 2, I have 29.5. Number 3, 0.5. Now, you need 3 significant digits. So 0.500. Number 3B, that was the one I just did, 4B. You again need 0.5. You need 4 significant digits, so 0.5 with 3 zeros behind it. Now, some of you may have put those two in scientific notation. If you did, 5 times 10 to the negative first. So you'd have like 5.000 times 10 to the negative first if anybody did that. Anybody put those in scientific notation? Okay, I thought I remembered you having it in scientific notation. So your number 3 would be 5.00 times 10 to the negative first to have the right significant digits, Howard. All right, number 5, 4.068 times 10 to the 24th. Now, you might not have the exact same number. Are you in the 4.0 range? Yeah. Times 10 to the 24th. Yeah. All right, you need 4 significant digits. And then times 10 to the 24th atoms. You might not have 0.068. It might not be exact. Number 6, 6.05 grams. 6.05 grams. You need 3 significant digits. Number 7B, 1.50 times 10 to the 23rd atoms. 1.50 times 10 to the 23rd atoms. Now, 8B, you should have drawn 2 charts. You should have found 6.02 times 10 to the 23rd atoms of fluorine and 5.66 times 10 to the 23rd atoms of neon. So which one would be larger? The fluorine would be larger. Now, which ones do we need to work? I'm not doing 8 problems, people. All right. Shh. The first thing you've got to do is be quiet. First of all, there are 29 people in this class, so you cannot talk as if this is a normal classroom. So number 2 says determine the mass, and you have 4.25 moles. So whoever asked for that one, if you have 4.25 moles, come on, today board. All right. 4.25 moles goes on top. Moles goes to the bottom, so it'll cancel. And if it says mass, what are they asking us to find? They're asking us to find grams. We put grams on top. Now, the 2 conversion factors that we learned yesterday were 1 mole equals 6.022 times 10 to the 23rd atoms. And 1 mole equals grams, and we had atomic mass next to it. So when you look at those 2 things that we learned yesterday, which one of these 2 fits this chart? The second one. The second one. So moles gets a 1 beside it, and grams gets what beside it? Atomic mass. So the question said Li, which is lithium. So you look on the periodic table to find lithium's mass, and it's 6.94. So 4.25 times 6.94 gives you whatever I called out. I have absolutely no idea. Is what? 29.5. Okay? And grams. All right, what was after 2?
4.
4, and I hear 5. Let's do 4 first. All right, number 4 says we have 3.011 times 10 to the 23rd atoms. All right. What goes on the bottom line? All right. That asks for how many moles in the questions. So if we started atoms, what has to go on the top line? Moles. Since the question said how many moles, we don't need a third section. Atoms to moles, we're done. Looking at these two, which one of these do we need? The top one or the bottom one? The top one. So what goes beside moles and what goes beside atoms? Avogadro's number. So 6.022 times 10 to the 23rd. Now, if you forget that number, does it exist anywhere that's useful for you? It's on the orange sheet. It's the very first number on the very first page. You can look it up. You did what? Kevin, you did what?
I've typed it into my calculator so many times I won't forget it.
That is probably true. For most of you, you will not forget it on a quiz or a test. But if you have a senior moment and you do forget it, you can look it up on your orange sheet. Okay? So, probably won't happen to you, but it happens to me regularly. So, not this number. I think it was 0.5. It is. So, you get 0.5. And, again, you need how many significant digits? 4. So, just fill in with zeros. Now, if you had scientific notation on your calculator like that, you could just make it 5 times 10 to the negative first. Any of those answers are fine. You can leave it in normal notation or you can put it in scientific notation. Either one is fine. Okay? Number 5. Number 5 says how many atoms are there? And you have 6.7755 moles. Okay? So 6.755 moles. And we're finding atoms. So what goes on the bottom line? And what do we put on the top? All right. Again, which of these two fit what we want for number 5? This one, right? So what's beside moles? And what goes beside atoms? Avogadro's number.
You just keep saying it.
Avogadro's number. And then all you have to do is calculate, right, Joyce? So, multiply and divide, and you get whatever I called out, which I have no idea what it is because it's not on the same page. It's 5. Thank you. 4.067 times 10 to the 24. All right. Anything else we need to do? I already did that one, didn't I? I would have swore I did 3. I did 4. 3 has 11.5 grams. Grams to moles. What goes beside moles? 1. What goes beside grams? Atomic mass, right? What element did they give you in number 3? Na. So Na's mass is 22.99. Divide, you get 0.5. We need 2 zeros. All right, mole. All right, I heard 7. Okay, 7 is the first one we have where we have to go from a gram to an atom or an atom to a gram. 7 says grams, so 8.02 grams. What goes on the bottom line? From a gram, we always have to go to a what? We have to go to moles. Moles has to be in your chart. You cannot get used to skipping those. From a mole, what goes on the bottom? Moles, and then go to atoms. So, what goes beside grams? What goes beside grams? Mass. So, what element did they give us in the question? Because I do not know. 7 had sulfur, S.
32.7.
Now, I would imagine everybody in the room has figured out at this point what is beside moles every time? Ones. Now, eventually, moles will not be ones. But we're not there yet. We will get there in the next few weeks. So, atom, what will it always have? Atom always has what beside it? Avogadro's number. So 6.022 times 10 to the 23rd.
Wait,
What?
number 2 didn't have one next.
Yeah, it did. Had one next to mole, and grams had 20. No, it was lithium, 6.94. Yes, my dear.
What's the abbreviation of
MOL.
Oh.
They dropped the E off.
Oh.
I use it some. I don't use it a lot because we'll do molecules in a few weeks, about a week or so. And molecule is MOLC. And so a lot of times with my bad handwriting, MOLC and MOLE, people can't tell the difference. And so I don't usually abbreviate them a whole lot. Do you need me to do 2 again?
No,
You sure?
I put 4.25 in front of mole, and I still got the same answer.
4.25 moles,
Yeah, right.
which is the given data.
Yeah, that's what I'm talking about.
Yeah, no, when I said moles always has a 1 in front of it, I'm talking about when you fill in the data here. That would be a 1.
Okay.
Not the original stuff they give you in the question. That won't be a 1. Okay? Anything else? Do we need more practice or are we comfortable
Yeah.
for a quiz?
No.
More practice, please.
Yes.
Okay.
Yes. Oh, yeah.
All right, take the same paper you have. We can borrow Chris's. How I make extra copies and I still only wind up with 1 sheet of paper left, I will never know.
Yeah. Are we gonna go over the quiz?
Do we need to go over the quiz?
No.
I was gonna say I didn't have but like 1 person failing. I didn't feel like I needed to. Let's do 3C, 4C, 6C, and 7C. We're gonna do those 4. And that's it. Once we've done those 4, I'm going to decree us finished and move on. And then we're going to move on to naming. I'm going to set the answers right here so you can check. If you have questions, by all means, ask me so I can provide aid.
Oh, good, dude.
Remember, you can check your answers anytime you want to. Those people who are doing it. Fabulous. If you need me, there you go. Put your homework ready, Jen. Not doing anything important. You actually know what you got. Okay, so it goes on the top. Oh, no, it's right here on the top. So, if that happens in those molds, what number has to go inside out? The thing for Zen, which is zinc, is always inside grain. The grain is the starting. You're not going to use it, but always goes inside out.
Oh.
Okay? You're always using. Anytime there's not a word.
Okay, sorry. I was wondering.
Every time.
Where did I do that? Let me see. I'll tell you.
Right?
Oh. I didn't get that. What did you do? Where'd you get it? This one, right?
Are we going to have
Not unless you have questions. If you have a question, bring it here. I can do what I'm doing later.
I just used the wrong numbers to make it wrong, see?
Then go look at the answer for the one you did.
I did.
And it was correct. That's fine.
Oh, I didn't.
I'm just trying to be nice, okay? Don't be like that.
Anybody need me?
I'm scared.
I'm feeling very useful over here. Yeah. I got it. Did you have it?
What did you do? No, we got it right. Yeah, you.
All right, let's see how you're saying. Times the ether. No time. Okay, you're gonna say 6.25 seconds.
Yeah.
And then say.
But so do I.
And then say.
You know what I think? This grade is the type of
The times it.
And it's Earth is our last.
6.022 seconds.
So should
And then say.
someone should say.
Yes. And then if you want to, you can say mode.
And then, we're back to the
All right, thanks.
I told my mom, I was like, I can't run because like, I can't feel sad. I can't be second. She was like, you do not understand. She was like, you don't even know that. And I was like, yeah, no, I'm gonna miss this stuff to where.
All right, you got plans.
I was about ready to cry. No, she but she had it. She kept bringing
How many more?
it. Oh,
Let's talk them all. Here. Start here. Put there. Said you got out. Number 6, that's 55.
That's what I kept.
Okay, I got the answer. She told me. That was the other question. All right, so number 6 is what is the math you get size. All right, so you're looking at it up. Got out. Start here now. Out of the bottom. Then I can what next? Long little topics you got. No more folds. No one on the bottom. And all we're gonna do a bar.
That's why, that's the only reason.
You got right on the bottom. Every time you wrote out.
After that, the blue.
You are still leaving. Every time you got balls. Every time you write grade. Where are you gonna find a way? What element you got? We have three C's.
I do too. Oh, I was saying. You know, I looked at
We start with, since you only got two right there, 4 grade.
What is that? Is it Adam and Brandon?
Well, you know, getting hurt. They don't think I'm
sorry.
I
You don't know what you're starting with. So you gotta have. So you're starting here, what I need to know. All that's you know. That never has to go away. Then you know you have to go like that.
Yeah, my brother like.
Every time you write out, you're putting out together. Every time you write down, does that make sense?
Not that. I just said, he looked at me and being forced into
All right. If you have not finished, the answers are still on my desk. All right. Now, you have a quiz tomorrow on the math that we have done thus far.
Thus far?
Thus far. So what math have we just done?
The most.
What's that parentheses stuff called? Give it a name. Average atomic mass. And what have we done with it? Mole conversions. Very good, Herman. So,
You were talking about like just the beginning.
no,
Well, do we still have to apply?
it's a quiz. I'm not giving you math since the beginning. That would be a test. All right. So now we're going to move on. Before we even do that, go put your calculators up. Before y'all are knocking them on the floor. We don't need calculators anymore today. Yes, ma'am. Yes, ma'am. Put your calculators away. We don't need any more today. Yes, dear. Yes, ma'am.
What she did.
Did something wrong.
Let me see.
Yes.
Answer is
37, I think. That's what I remember somebody telling me. No, you haven't. 6C? You had something like that.
I looked at that.
You had something like that.
What are these?
What's the word? 4.50 second EE. What'd you have? 12 times
34.45.
it's 35.45. 35.45. Yeah.
I'll put 4.
All right. Now, if you're, I'm missing one calculator, probably Annabelle's. Now, we're going to talk about nomenclature for the remainder of class.
Boy, what?
Who came up with it? Just stop. These are imaginary words.
They're not imaginary.
She said they are.
Nomenclature is a Latin word, and it just means system of naming. And it's not even unique to chemistry. Okay? Nomenclature is used in lots of disciplines. So you may hear the word in other areas, not just chemistry. Okay? Now, we're going to use nomenclature in here because you have to learn how to name compounds. Now, we're going to use the IUPAC system. Now, we will only talk about this one time, and at the end of the year, you'll go, what's that called again? It's called the International Union of Pure and Applied Chemistry. Now, before any of you memorize that, you do not have to know it. You do have to know that the system you're using to name is called the IUPAC system. Now, we're going to learn to name with the stock system, which you will hear me say many, many times, and the old or the prefix system. Both of those fall under the IUPAC system. Now, you may or may not see the IUPAC system listed in a question, but on your exam, you will have to, no, everybody does that even regular. On your exam, if it says, what is the name of blah, blah, using the IUPAC system, just know that is the way we've learned to name all semester, and the state is not trying to trip you up, okay? Now, before we go into stock and the prefix system, we have to talk about two types of compounds, because this is where things get a little dicey. The stock system can be used for all compounds, which is why we will spend the most time there. My S is not going to fit, so it needs an S on it. The old system or the prefix system can only be used for covalent compounds. So, I'm going to talk about that in a minute. Since the old system or the prefix system can only be used for certain types of compounds, can I only teach you to name in that system? No. So, covalent. And then CMPBS is the shorthand compound. So in biology class, y'all learned CO2 was called what? What's its name?
Carbon dioxide.
That's an old system name. Still hangs around. Lots of people use it because everybody knows CO2 is carbon dioxide. So, H2O is water. It's just a common name. Now, because we use carbon dioxide, it's part of your curriculum, and I have to teach you how to name with the old system or the prefix system. However, a lot of compounds cannot be named using old system. If I taught how to name FeO with old system, I'd have to teach you the Latin root.
That means ugly.
Well, most of you do not want to learn how to name using Latin roots. So we teach using the stock system. Okay? But the state wants you to know both systems. So before we can do that, we have to talk about the differences between ionic compounds and covalent compounds. Some of you might remember a little of this from 8th grade.
Oh, no.
It is,
We learned this?
you should have learned the difference between ionic and covalent in 8th grade. Should. Now, an ionic compound has a definition that talks about its electrons and whether they're lost or gained. We'll talk about that probably 4 to 5 weeks from now. Not going into that currently, okay? We're going to talk about how to recognize them today. An ionic compound is a metal and a non-metal. Now, that's any combination. It can be one metal and one non-metal. It could be two metals and one non-metal. It could be one metal and two non-metals. Doesn't matter. It's any combination that is a metal and a non-metal. A covalent compound is a non-metal and a non-metal. Some people prefer to think of it as all non-metals. It doesn't matter to me how you attach that into your brain, but a covalent compound is just non-metals. We will not learn to name anything that is strictly a metal unless it is a singular element, like iron.
How have you dealt with this for so long?
What?
Them. Right.
Let's tune them out.
I cannot. I don't understand. Oh. Hold on.
It's usually not as bad as that is right now. But it's because they have Emma to work with them, so they split off into groups. Normally, Ms. Rector doesn't have an able-bodied assistant.
Well, I don't understand how you, like, sometimes you send them in here. I'm like, no, you cannot come to my classroom. Go outside. You're too nice.
Right now, I have an entire class that's being taught in my class during my planning period. I just put in my earbuds and turn up my music and go.
We got. I'd be like Mr. Cruz and other things. Okay, the first part, the second part of his piece.
We're not having any kind of discussions about that in here. Like at all. Now, moving on. So if we look at this periodic table, okay? Where are the metals and the non-metals?
Bro, what is that?
Oh, we did learn this in the middle.
Oh, yes.
What's in the middle? Okay, tell me this. What are the stairs?
That's the different.
The difference between the what and the what?
They're those green ones.
They're the green ones. They're the metalloids, in case you forgot that, okay?
Oh my God.
But we don't have to worry about the metalloids right now because we're not talking about it. Okay, so I want to know where the metals are in relation to the staircase.
In the middle.
Okay.
God, I remember now. Like that just like pulled back.
Another metals or anything?
Right.
Gold.
Okay, the metals are on the left of the staircase. Scratch that middle out of your brains. Okay, the answer is never, ever in the middle. Okay? I don't care what they taught you. It will never be the answer on any test ever in your lifetime. All right, the metals are on the left of the staircase. Yes, I understand why they told you they're in the middle. Okay? If you look on this lovely periodic table over here by my left shoulder, all right, over here, you have a periodic table. It's got a lot of lovely cartoons on it. Someday when you have a chance, check them out. They're kind of funny. All right, you see all that blue? All that blue is metal. It's referred to as the left of the staircase. Yes, it does occupy some in the middle of the periodic table, but we refer to that affectionately as the left of the staircase. So, where does that put the non-metals?
On the right.
On the right of the staircase. Okay? So the non-metals, all right, are on the right of the staircase. Now, there's one glaring exception to that. What one element is the exception to that rule that we just talked about?
Helium?
Not right, not that one, but you're, I think, thinking the right element. You just said it wrong. Nope, carbon's the pencil you're writing with.
Oh, wait. Yeah. Oh, man.
Now, if it's an exception, it has to be on the wrong side of the periodic table. Y'all are clearly naming gases that are on the correct side. Yes, hydrogen. Hydrogen is over here on the metal side, and it is a non-metal. Okay? And we'll talk about why it's over there when we study the periodic table itself. Okay? Everybody with me so far?
Yeah, we were supposed to draw this. I was looking at the wrong side.
It's up to you. Do your own notes. You do what you want.
You were just saying.
I told you that. I was going to do it many times this semester. I have not let you down yet. Now,
Started drawing cursive. I see little fancy.
all right. I want you very quickly to tell me if those are ionic or covalent compounds. Very quickly. Use your periodic table. There's only 4 of them, so it won't take you very long. I want you to tell me if they're ionic or if they're covalent.
Why are we writing this?
I want to know if they're ionic or they're covalent, because it will be important down the road. I go find another bottle of water.
My kids for that really, yeah. So that's
So that's pretty. So it's gonna be S. Okay, got it.
All right, we got it done?
It's on the left side. It's K.
Oh, help me.
All right. What can you tell me about CO2? Where's it at? It's covalent. If you look up here on the periodic table, for any of you who couldn't find them, CNO are both over here on the right. Okay? So that's covalent. What can you tell me about NaCl? It's ionic. One's on the far left, one's on the far right. What can you tell me about PCl? It's covalent. And what can you tell me about K2SO4? All right. What if I give you one like this? What's HCl?
Hydrogen.
All right. Don't let hydrogen trip you up, because hydrogen's way over on the left and chlorine's way over on the right. That one is often missed on quizzes and tests because people look at this and they go, oh, it's way over on the left, so it's got to be ionic. That is still a non-metal, so it is covalent. Everybody okay with that? Okay. Now, being able to identify these will be important about, best guess, late Monday when we start differentiating between how to name. Okay? We're going to start easy today, and we're going to start with ionic. Okay? Covalent is harder, so we're going to start easy, just for Annabelle. Okay? She'll whine less. I'm all about less whining. All right, so we're going to start with binary ionic compounds. So, binary means what, first of all? Okay, so we've got to identify a cation and an anion. What's a cation again? We just did this the other day. It's not a cation.
This is
I know you only did that to irritate me.
This is a different topic, right?
Isn't it?
Yeah.
You can give it another title if you want, but it's the same concept.
It's a positive
Positive charge?
It's a positively charged ion. Okay? What's an anion?
Negative.
Negatively charged ion. So, some examples might be like Na+1, Al+3, Mg+2. Some negative ones might be O-2, Cl-1, and -3. Now, what did we say the charge told us?
How many electrons
Are
gone or, misgained or, lost?
there you go. Charge tells the number of electrons lost or gained. Now, we use the charge to write formulas and crisscross. Now, we have a slight issue. Y'all know the oxidation numbers or the charges? Of course not. Because I'm told to. Now, I am going to teach you how to find them by the end of the semester. Because I teach the course, some people would say completely backwards. I've only met one other person who teaches it the order I do in 28 years. Because I teach it backwards, I don't remember the name. I give you the oxidation numbers to use right now. But you only have this chart temporarily. Because eventually, I will have taught you all the skills you need, so you do not need this chart. Will you have this chart on the exam? No. Because it's not orange. It's a good reason I didn't think about that. I didn't make it orange. Hold on, grab some more. All right. You get this essentially until day 60 of the course. We're on day 12, if that gives you any idea. All right, we're on day 12. All right, by day 60, you will not get this chart anymore. I mean, you may keep it, but you cannot use it on any quizzes, any tests. But as long as we're below day 60, you can still use it.
Brother, how do you expect me to memorize it?
But, so, you're not going to memorize it. I'm going to teach you skills of which you can use to find this stuff. Now, I wrote oxidation numbers up there because I know them. I know how to find them. You're going to figure out how to find them and know them also. But there are 4 things you do have to memorize, and there are 4 acids. So if you turn to the back, you might want to star them because you do need to know them. Our first quiz on naming best guess is going to be Tuesday of next week. You must know them by the first quiz.
Know what? Know what?
On the back, find where it says common acids. They are the bottom 4 acids. Okay, so hydrochloric, sulfuric, nitric, and phosphoric. Now, some of you are like, this woman's stupid. She just told me I could use this chart on every quiz or test.
Right, except that one.
Can't use your chart. So on every quiz or test, I will give you my oxidation sheets. Guess what they're missing? Those 4 acids are missing.
And
Okay.
you really think you're something.
I know it. Okay. So, on Tuesday, you have a quiz on naming. There might be one of those acids. There might not. But there might be. Just for Annabelle.
So we just have to know how to make them?
Or write their formulas. So if I write HNO3, you write down the name as nitric acid. If I write sulfuric acid, you write the formula as
H2SO4.
correct.
So you want us to memorize this?
Exactly. Now, moving back on to naming. Am I checking hands? No, but if I catch you cheating, you have a 0, and then I call your parents, and they just get pissed. All right. They get mad. Now, moving on. We're going to learn to write formulas today. Now, if you had, again, a pretty decent 8th grade experience, a lot of 8th grade teachers will teach this concept, okay? So, we're going to start easy and write formulas for binary.
Should I call it practice?
I don't care what you call it. Now, what does binary mean again? 2. And what does ionic mean again? What was ionic a minute ago?
Metal.
A metal and a non-metal. Okay, so we're talking 2, and we're talking a metal and a non-metal. That's what we're starting with today. So, the first thing we're going to do is look up the symbol. Now, some of you think I'm nuts by telling you to look up the symbol. But let me be clear. There is no partial credit in naming. There's none. So if you write down the wrong symbol and every other thing is correct in the name, it's wrong. Okay, so fluorine, what's its symbol? I heard F and I heard FL out there. F is correct. FL is wrong. So if you had accidentally written FL, your answer is wrong. When I say sodium, sodium is Na. But sometimes I get S, sometimes I get SO. I mean, sometimes you just do the weirdest things on quizzes. I've seen some bizarre stuff in 28 years. Okay? You do that silly stuff and you lose points. Okay? So if you're not certain, look it up. All right, number 2. Look up the oxidation number. After you do some of those a few times, you'll be like Kevin. He's like, I'm not going to need to look up that Avogadro's never miss wall. I punched it in my calculator so many times last night. I got that. Okay? Oxygen is one of those after we look up a few times. Tomorrow or the next day, you're going to be like, it's -2, Ms. Wall. You're going to do that one so many times, you're going to have that oxidation number. You may not need to look that one up. But a few of them, you're never going to remember. You're going to look those up a lot. All right? Number 3. We're going to, let me fix something first. Let me put in a tidbit to help you. The positive element is always first, and the negative element is always last. That'll help a lot of you in a few minutes.
What if you have more than 2?
The middle element can be positive or negative. A lot of times it's going to be positive, but it could be either or. But if you have 3, the first one's always positive and the last one's always negative. But remember, right now we're talking about only 2. All right, now number 3. All right, criss cross the oxidation number only. We don't need the positive and negative at that point. We're only crisscrossing the number. And number 4, reduce if necessary. Step 4, you will not have to use very often. Okay, it's a lot like math class. Every now and then you get a fraction like 2/4, and what do you have to do if you get a 2/4? You reduce to 1/2. Okay? But every now and then we'll get something we'll have to reduce. We don't get it very often, but sometimes we do. Am I giving every? Oh, I see several people still writing. I didn't write that much. I tried to consolidate.
You trying to do 5 minute water bottle too? Can I do this water then?
Yes, you may. All right, I'm giving everybody enough time now. All right, so let's say that we want to write the formula for magnesium chloride. Okay? Now, what is the symbol for magnesium? Mg. What's the symbol for chloride? Cl. Okay? Now, step 2, we need their oxidation number. If you look at the front side of your sheet, let me grab one real quick. There are actually 2 halves to the front side of this sheet. Because, I thought I was super smart and I wasn't. So, let me explain to you how this works. So, tomorrow we're going to do polyatomic ions. So, just sort of pretend these 2 columns right here don't exist.
Right there.
Okay? Just sort of pretend these 2 columns don't exist right now. Okay? We'll get to them tomorrow. So, you got 3 columns you're essentially looking at. The first column is the name of the element, the second column is its symbol, and the third column is its oxidation number. Those last 2 columns are polyatomic ions, and they're mostly alphabetized. That's the part I didn't do too well with the table because, I'm not a word specialist. Okay? On the back side, if you flip it over, again, ignore those last 2 columns, are the remaining elements, their symbols, and their oxidation numbers. Okay? Now, if you look at magnesium, what's its oxidation number? +2. Now, look at chlorine. What's its oxidation number? Okay, -1, +1, +3, +5, and +7 is what's listed on the card. Now, given all that's listed on the card, how are you going to know which one to pick? That's why I told you what I did number 2. The positive element is always where? The negative element is always where? So if we go back to those numbers you just told me, which one has to be chlorine's oxidation number?
You put chloride.
I'm going to explain where chloride comes from when we write the names. All right? As long as you're writing a name that ends in IDE, it's still chlorine. All right? Chloride or chlorine has to be -1 because it's last in the name. It has to be the negative oxidation number. It can only be positive if it's written where in the name. The first. Is chloride or chlorine first in the name?
So if it was chloride, magnesium, it'd be.
It could be one of the others, but it's not, so it can't. So it's the -1. So chlorine has a -1 oxidation number because it's written last. Okay? Are you with me on how we figured that out?
Yes.
Okay. Now, step 3 is to crisscross. We only use the number, not the sign. Why I said here, crisscross the oxidation number only, the number. So, I don't need the positive. I don't need the negative. All I use that for is to make sure everybody's where they belong. Is the positive guy first? Is the negative guy second? They're in the right place. So I'm crisscrossing. The 2 comes over here to chlorine. The 1 comes over here to magnesium. Now I'm going to rewrite what I have because we're not keeping all this mess. So Mg has a 1. Chlorine has a 2. Now, you need me, Miss Farley, or you need somebody? Here, move over from where we're recording here. No problem, unless you want to be on YouTube.
No.
All right, so when you look at this, does 1 and 2 reduce?
No, I don't know.
No. In math class, can you reduce a 1 and a 2 any lower than it is?
No.
No. So we don't need to do step 4. And just like in math class, do you write x to the first or do you just write x? Just x. Okay. So I'm going to take that 1 off and not write it. So that would be your answer.
So does it matter if you rate it or not?
If you guys need to write it for a day or so, it's okay. Now, I would hope after a day or so you would get the hang of not writing the 1, given, we are in honors chemistry.
So
If you do, I will not take off for it, Annabelle. It's fine if you do. I will not be writing it, okay? So you're going to have to adapt and be able to recognize that I'm not going to write it on things. But if you need to write it, I won't take off for it. Yes.
So if it's a number other than 1.
It has to be written.
Okay.
Yes. Okay? Everybody good?
Yeah.
So let's say we do aluminum sulfide. All right? What's aluminum?
I say aluminum. I feel like I'm saying anemone.
Hey, at least you got 15 minutes.
I know, you must be the honors group there.
You must be.
I made a fabulous storyboard. I texted you.
Yeah, I saw that. We did a storyboard too. All right, so what is sulfide? S. All right, so what's the oxidation number for aluminum? All right, let me give you a hint. When you look at this column, for those of you who are struggling, these are alphabetized.
Yeah.
Okay, so when you look up aluminum, they're alphabetized here. So if I show you alphabets, I'm going to struggle with that myself. I'll admit it. And I'll look at them like, A, B, C, D. All right, so look up aluminum, find the symbol, and then the oxidation number's right there.
Yeah.
Okay, side by side. And then when you do sulfide, sulfur, whoop, no S, look it over to the back. Look up sulfur, and then you got S, and you got all those oxidation numbers.
Yep.
Sulfur's last, so which one do you have to pick? Are you with me? Does that help you find it a little faster? Okay, because I don't want you working on your homework, till like midnight.
If this is what it is.
And before you even complain, my daughter took it at West, and her homeworks were usually 80 questions long. So don't yell at me about 10 questions.
Oh, I
Yeah.
thought you were about to say, like, 30.
No, I'm like 10. Huh? Yeah, she took chemistry. So, and even I was appalled at what her homeworks were. So, when we look at this, what do we do with the plus? Get rid of it. Get rid of it. 2, 3, and we get Al2S3. Can we reduce the 2 and the 3?
No.
And it's good. Everybody got it? Now, let's add a little kink to the question. You know it can't be just that easy all the time.
Oh my God. Oh my God. I'm gonna try it again.
What is the V?
Just as a side note, before we even write this,
What is the V?
yeah, we've been down that road before, but everybody struggles with that.
Oh, I did.
All right, there's Roman numerals 1, 2, 3, 4, 5, 6, and 7. For anyone who might not know 1 through 7, okay, you have to be able to use Roman numerals 1 through 7 in here. Okay, first of all, no, listen to me carefully. No oxidation number for us will exceed 7. So if you find an oxidation number greater than 7, something should trigger in your brain that says
Wrong.
yes. Okay, so we're going to write this formula. You've probably noticed on your sheet that some of your oxidation numbers are positive. How are you going to know an oxidation number that's positive if there's more than one? I have to tell you which one to use. So look up manganese, for example. So manganese, when you look it up, has oxidation numbers of has all those listed, right?
Yes.
And it's first. So you just know it has to be positive. So I have to tell you which one to use. This right here is the first element's oxidation number. So I'm telling you that manganese has a +6. Okay, that's the one I'm telling you that you have to use. You don't get to choose the 6th one on the sheet. You have to use +6. Does that make sense?
Yes. So if it was a Roman numeral of the second,
Then you'd use +2. Whatever Roman number is there is the Roman number you use. Okay? So if I'd written Roman number 2, Faith, that means I'd have written +2 here. Okay? If I had a 4, I'd use +4. Does that help?
Yes.
Okay. So then I have oxide. What element is oxide? That's oxygen. So I write O, and O has what oxidation number? -2. Okay? Are you with me so far?
First cross.
Okay, so we're going to get rid of the positive and the negative. The 2 comes down, the 6 comes down, and I have Mn2O6. Now, this time, what can you tell me about my numbers? We can reduce. So this time we have to reduce. So we should look at these and say, just like in math class, what could a 2 and a 6 reduce into? They can both be divided by 2, right? So this can become a 1. This can become a 3. So I'm going to reduce that into MnO3. Okay? Now, if you forget to reduce, it's the only thing I will give you partial credit on.
Yeah, that's what I'm going to forget.
Are you with me? Am I on time? I got 10 minutes. All right, let's do one more with that. Now, will Roman numbers ever be at the very end? No, they will only ever be in the middle for y'all. Let me see. I already did that one. All right. This should be an easy one. You write it, and then we'll check it.
Iodine.
Mm-hmm.
The iodine.
Mm-hmm. Yep, we're going to talk about the endings
This
tomorrow.
is 2, right? Because you didn't put lines over it.
Oh, yeah, you did.
Yes.
Yes.
Well, you can't do that. It's 11.
Really?
So really, we just have to like memorize one number, or we do. Like we just like the first number, like you know how iodine has iodine. Like it has the different oxidation numbers, but can we just memorize one? Since that's what we need.
Right.
She told
You
you.
only got one?
You don't have to memorize those. You only got to memorize back 4, you silly.
You only got to know the 4 acids. You get to use the chart.
Oh.
I'm just giving
have to
you
remember common acids.
those 4 common acids. I'm going to give you a chart. I'm just giving you mine, not yours.
Oh.
The ones we started, that's good for memorize.
Well, I knew that, but
See, it's just going to look like this.
We'll be done. Much longer.
Orange.
I thought we were.
Some of the whites and the yellow.
Yeah.
It's just missing those last 2.
I
Otherwise, it's identical. Okay? Yes, Herman.
So like on the final test, you have to have this whole thing memorized?
I promise. No. right. So what do we come up with? N-I-2. Everybody good? Okay. Let's talk homework. Before y'all die. Y'all are that bad off?
Yeah.
That's terrible.
I started the day off bad.
What's so bad about today?
Math. It's Thursday.
Wow.
She won't take a break with me.
All right, on the paper that Karen is handing you, we're doing 1 through 8 on the front side. That's it.
1 through 8.
1 through 8.
No complaint.
Do not work ahead, please. You don't know how to write names. I'm pretty sure I've not taught how to use the Roman numbers for the endings yet.
Nope.
You are only doing 1 through 8. Pretty short. You also have a what tomorrow? Quiz. And I don't like to grade a whole lot on the weekend, so could you please do well on it?
I hate
Somebody tell Takira what's on the quiz tomorrow. She's already forgot.
math.
You remember what math?
The moles today.
The moles and the AMU. How did I have all these papers today? Yesterday I got one lone sheet of paper and we have the same number of people asking.
Did you come in the same number?
Yes, I did. I made 31. That's my question.
Maybe they got lost.
Did everybody get a sheet of paper?
Did everybody get a homework sheet?
Sir.
Okay, I don't understand.